Our next lesson is about significant figures. We always say Sig Figs, okay? So our learning target, I will determine and apply significant figures in measurements, perform rounding according to significant figure rules, and utilize significant figures to present mathematically derived answers. Okay, so basically, significant figures are numbers, right? We're looking at a number and we're trying to figure out what part of that number is significant. Okay, so what I want you to do is I want you to take out your calculator. And I want you to divide 15.7 by 237.9. Okay, so I did that. It's up here on my screen. And you'll notice that the calculator always gives you way more numbers than you need. Okay, how do we know which numbers to write down? I don't know about you, but I don't want to write down like, I don't know, it looks like there's 25 or 30 numbers there, right? So the answer is writing only the significant figures. Okay, so significant figures are the digits that carry meaning in a number and contribute to its precision. So if we go back and we look at that number again, all these numbers down here, right? We don't even have measuring equipment that would be able to measure to that point, right? We could maybe measure out to where the 0.06599 is, right? But I don't think we could go any lower than that, at least not here at Cooper. Okay. They also help to indicate the precision of the instrument that you're using. If you're using a ruler, like a meter stick, you're not going to be able to measure all the way out here, right? Meter sticks measure in centimeters, so that would mean that the most you could do is 3 digits after the decimal point. Okay. Significance is usually tied to the zeros within the number. I know that sounds weird because, it's a number, but the zeros actually mean specific things. Okay. All right. So if you need to understand first you need to understand some basic rules. Okay. So when we're looking at a number, let's say this number is 0.0050830. Okay. These first 3 zeros, okay, those zeros are important, but they're not significant, right? Because we could write 0.00 and it still just means 0, right? But once we put a number after those, that's when it starts to get significant. Okay? So all non-zero numbers are significant. So in ours, 5, 8, and 3 are significant. Okay? Zeros in between two non-zero numbers are significant. So our 0 right here is significant. It means something. Okay? And then trailing zeros at the end of a number only if they're on the right-hand side of the decimal point. Okay, so here's the decimal point. This happens to be on the right-hand side of it. This one is actually significant. Okay. What's not significant are the zeros that begin a number, right? These zeros, they're not significant. They're important, but they're not significant. Okay. And then zeros at the end of a number on the left-hand side of the decimal point. Okay. So if I wrote the number 20,410, right? The 0 at the very end is not significant, right? All right. So if we count the number of significant figures in this number, right? Remember, the zeros at the beginning are not significant, so we don't count those. But we can pick up at the 9. So 9, 8, 7, 6, 5. Those are all non-zero digits. So all 5 of them count. Okay? And then the 0 at the end is on the right side of the decimal. So that one counts. So that means that there are 6 significant figures in that number. Okay? If we're looking at this number, 12,345,000, okay? The 1, 2, 3, 4, 5, those are definitely significant. But the decimal point should be right here, right? And that means that these 3 are on the left. They're not significant. So there's only 5 in that particular number. Okay? This one, we have 1, 2, 3, 4. So those count, right? Those are regular numbers. And then these zeros are on the right side. So you would think they wouldn't count, but they're in between 2 regular numbers, right? So all 3 of those count. So 1, 2, 3, 4, 5, 6, 7, and then 6 counts. So it'd be 8. Okay. Counting significant figures can be a little bit difficult, but in this class, we're only really needing 3 and 4 significant figures. So it's just understanding how to round them once you understand how to count them. Okay. So, like I said, we do normally only use 3 or 4 significant figures. And so we're going to need to round them. Okay. Make sure you know how many significant figures you need to round to. Okay. So your problem should tell you if it needs to be more or less than 3. Okay. All of my answers in Schoology are 3 significant figures. Okay. So starting at the first significant number, count moving to the right the number of digits that you need. So I have this number 1, 2, 3, 5, 5, 6. Okay. I only need 3. It's telling me I only need 3. So I start at the first number and I say 1, 2, 3. Then I'm going to look at the next number. If that number is a 5 or higher, you're going to round the number next, the last number, up, right? So because I had a 5, I now change this to a 4, and then all the numbers after that become 0. Okay. And then if I have a number 0.01235, again, the first significant number is the 1. So we have to count. These don't count. 1, 2, 3. Look at that 5 and then round up, right? I still have to write these zeros. These zeros are important, but they are not significant. Okay, so it'd be 0.0124. Okay, all right. And if the number after is 4 or less, again, you just leave that number the same. Okay. Rounding significant figures after a math operation. Really, the only thing you need to know in any math situation, we're mostly doing multiplication and division, is that the number with the smallest number of significant figures is the number of significant figures that you should put your answer in, right? So the first thing that you do is determine which value has the smallest number of significant figures. So in our example, 45.2, that one only has 3, and the one underneath it has 1, 2, 3, 4, 5. So we want to go with the smallest. Okay. Then in your calculator, do the math. Okay. So your calculator is going to give you, that big long number. We only want 3 because the smallest number of digits in the actual problem is 3. So we're going to do 1, 2, 3. The number after that is a 9, so it'd be 7.11. Okay? All right. So here are some examples of rounding to 3 significant figures. Again, all of our answers in Schoology will be rounded to 3 significant figures. It's kind of the norm. I mean, there really isn't a lot of numbers out there that you have to use more than 3 or 4. Okay. All right. So if our measurement is 123,450, we would round it. We'd go 1, 2, 3. There's a 4 afterwards. So the 4, 5, and 0 turn to zeros, and our answer is now 123,000. Okay. Again, on the next one, 1234.06. Again, we want 3. So 1, 2, 3. The 4 becomes a 0, and anything after the point just gets thrown away. Okay, so it becomes 1,230. This big long number. Okay, again, count 1, 2, 3. The 3 makes the 1 stay the same, and all the other numbers become zeros. Okay, but since it's such a long number, it might be easier to put it into scientific notation. Okay, so 981, and then 1, 2, 3, 4, 5, 6, 7 zeros. Then if we change that into scientific notation, the decimal point goes from here to here, right? So that gives us 2 more. So it'd be 9.81 times 10 to the 9th. Okay, now remember, 10 to the 9th is also the same as nano. So instead of writing 9.81 times 10 to the 9th meters, we could write it as 9.81 nanometers. This is significantly smaller than writing this or writing all of the zeros. Okay. And then the same thing with ones that are on the right-hand side. Find the first significant number. In this case, the 9 is the first significant number. Remember, all these zeros, they don't mean anything, but they're important. Okay, so 98765. So 1, 2, 3. The number after it is a 6, so that means the 7 gets raised to an 8. Okay, and then if we count, we have 1, 2, 3, 4, 5 zeros in front. If we move the decimal point to where the 9 is, that would make 6 zeros in front, or 6 numbers in front of the decimal. Okay, that's how we get our -6. Positive is numbers greater than 1. Negatives are numbers between 1 and 0. Okay, so in this case, we have 9.88 times 10 to the -6 meters, or again, -6. That is one of the prefixes, which is micro. So we could write 9.88 micrometers. So to sum it up, significant figures are used to write long numbers. We talked about counting significant figures. That's really only so that you can figure out how to round to the right number. And so we also talked about rounding. derived answers or mathematical answers to the correct number of significant figures.